These are the notes for today, writing fractions in lowest terms. And as a note, the goal when it says to write a fraction in lowest terms is to eliminate the common factors between the numerator and denominator. And I'm going to show you 3 examples of what I mean by that. So example 1 is asking us to write 4/8 into its lowest terms, aka simplify the fraction or reduce the fraction. So the first thing I recommend is to do the prime factorization for the numerator and denominator. So I'm going to do the prime factorization for the 4 and for the 8. And here's just a sample of the prime numbers, 2, 3, 5, 7, 11, 13, and 17. So I'm just going to break down the number 4 into its factors. So I could use 2 times 2 and just look at the list. 2 is the prime number, so I'm going to stop there. That's the prime factorization for 4. And the same idea for 8. The factors of 8 could be 2 and 4. This is prime and this is not prime. So again, you have to refer to that list. 4 is not in the list, so it's not prime. So I could do the prime factors for 4 would be 2 and 2. And I'll circle those right there. So I have the prime factorization for 4 and for 8. And now I'm just going to rewrite the fraction 4 over 8 based on the prime factor. So 4 is the same as 2 times 2. So I'll put 2 times 2 there. And then 8 is the same thing as 2 times 2 times 2. So I'll put that in my denominator. And going back to the goal, you want to eliminate the common factors. So I see these are common factors between the numerator and my denominator. And again, these are also a pair of common factors. So I eliminate those 2. And as a side note, don't forget, like 2 over 2, if you're looking at the fraction 2 over 2, that's just 1. So when we eliminate the common factors, we're essentially saying that this is really the value 1, this has a value of 1. And you'll notice that I eliminated all the factors in my numerator. If that ever happens, you could always put times 1 if you don't have enough numbers left over. In other words, they all disappear. So now I'm going to put the 1 as my remaining factor and 2 as my remaining factor. And that lets me know that 4 over 8 and 1/2 are the same thing. They're equivalent. The only difference is we eliminated the common factors, and now this is what we call 4/8 in its lowest terms. 4/8 in the lowest terms is 1 over 2. All right, here's the next example. We're going to do 18/30ths into the lowest terms. So it's the same thing. You're just going to do the prime factorization for each of these numbers. So 18, I can write it as 2 times 9. 2 is prime, 9 is not prime, so I'm going to break that down. This will be 3 times 3, and these are both prime numbers. So that's my prime factorization for 18. And then for 30, that's the same thing as 5 times 6. 5 is prime, 6 is not, so I'm going to break this down further, and this will be 2 times 3. These are both prime, so I know the prime factorization for 30 is 5 times 2 times 3. So now I'm just going to reorganize this. My 18 is the same thing as 2 times 3 times 3. And then 30 is the same thing as 5 times 2 times 3. And what I recommend is putting them in order from least to greatest. You don't have to, but I noticed that it does eliminate mistakes. So I'm going to put, instead of putting it in the order of 5 times 2 times 3, I'm going to do 2 times 3 times 5 over here. And the reason why I do that is because it allows me to see which ones match up a little bit more easily, and I don't miss out any common factors. So this is a common factor that becomes 1. 3 over 3, that's another one that eliminates to become 1. And you can see we're left with 3 over 5. So 18 over 30 is equivalent to 3/5. And this is the value, 3/5 is the 18/30th, and it's, as they stated here, the lowest terms. So again, we eliminate the common factors. What is left is the fraction 18/30th in its lowest terms. So remember, in its lowest terms, even though they look different, they have the exact same value. If you were to divide this out in a calculator, 3 divided by 5 will be 0.6. If you divide this in a calculator, 18 divided by 30 is also 0.6. It just looks different. And then for my last example, we're going to do 30 over 84 to lowest terms. So for 30, I know I could write that as 5 times 6. Just like we did in the previous one, you'll be able to recycle some work that you already did. But in this case, let me just switch it up. Instead of putting 5 times 6, I'm going to do 10 times 3. So you can see that even though I started with different numbers, you do end up with the same answer. 3 is prime. The prime factors, or two numbers that multiply to give me 10, would be 2 times 5. So you can see I ended up with 3, 2, and 5. And again, same thing, 3, 2, and 5. So it doesn't matter which numbers you pick in the beginning. As long as you do the multiplication correctly, you'll end up with the same answer no matter what. And then for 84, I could do this as 2 times 42. This is prime. This is not. This will be 2 times 21. So this is prime. This is not. And then this will be 3 times 7. So that's my prime factorization for 84. So now I take my fraction 30 over 84, and I'm going to write it down as its prime factors. So 30 was 3, 2, and 5. I'm I'm just going to reorganize it least to greatest. And then for the 84, 2, 2, 3, 7. 2, 2, 3, and 7. And now just look for the common factors. So in this case, these are in common. These are in common. There's a 5 here, no other 5s. So nothing else matches up. So I'm left with 5 in the numerator. And in the bottom, the denominator, 2 times 7. If you end up with more than one factor, just multiply them back together. 2 times 7 is 14, and that'll give you your final answer. So 30 over 84 in its lowest terms is 5/14. And as I mentioned before, if you want to see if you got it right, divide this in a calculator. It should be the same answer as dividing this in a calculator. And here's some bonus examples. So 6 over 9 in the lowest terms. 6 is the same thing as 2 times 3. These are both primes, so that's the prime factorization for 6. And 9 would be 3 times 3, and these are both prime as well. So that's the prime factorization for 9. So 6 over 9, 6 is the same as 2 times 3. 9 is the same as 3 times 3. Eliminate the common factors, so we're left with 2/3. So again, if you want to know if it's right, this divided by this should be the same as that divided by that. So you should get 0.666 repeated for both of these. And one thing you'll notice is sometimes, the smaller the numbers, the faster the work is. But when you end up getting bigger numbers like this one, your prime factorization will get bigger, which means it'll just take a little bit more work. It gets more complicated because there's more steps, but the goal remains to be the same. You're just eliminating common factors. All right, so here is 24 over 27 in lowest terms. So I'm going to do the prime factorization for both of these. So for 24, I could use 3 times 8. 3 is prime, 8 is not, so that could be 2 times 4 here. And then this is prime, that's not, so this will be 2 times 2. And you can see my prime factorization is complete for 24. And now I do the same thing for 27. That would be 3 times 9. 3 is prime, 9 is not. This breaks up into 3 times 3, which are both prime. So the prime factorization for 27 will be 3 times 3 times 3. So putting this in lowest terms, I'm going to take the 24, rewrite it to its prime factorization. 2, 2, 2, 3. So 2 times 2 times 2 times 3. And then 27 would be 3 threes. So 3 times 3 times 3. So here I can see I only have one pair of common factors, nothing else. So now my final answer would be multiply these together. 2 times 2. This is a common mistake I saw, so be careful. When you multiply this, a lot of students put down 6. So be careful with that mistake, because 2 times 2 right here, if you multiply these together, you get 4. And then 4 times 2 is actually 8. So be careful, because it's a natural thing to want to say 2, 4, 6. But remember, you're multiplying these all together. You're not adding them up. And then my denominator here, 3 times 3 is 9. So 8 over 9 is my final answer. And then here is the last example. So 52 over 60 in its lowest terms. So I'm going to do the prime factorization for 52 and 60. So for 52, I could do 2 times 26, which would be prime here. This is not. And that would be 2 times 13, which happens to be both prime there. And then for 60, I know I could do 2 times 30. This is prime, this is not. That would be 5 times 6. This is prime, this is not. So this will be 2 times 3. These are both prime, so that's the prime factorization for 60 right there. All right, so 52 over 60. So the 52, the prime factorization will be 2, 2, and 13. So multiply those three numbers together. 2 times 2 times 13. And then for 60, that will be 2, 5, 2, 3. So I'm going to put it in order least to greatest. So it'll be 2, 2, 3, 5. So 2 times 2 times 3 times 5. So here my common factors would be a 2, pair of 2's here, another pair of 2's here, and then nothing else matches up. So my numerator is 13. My denominator will be 3 times 5, which is 15. So my final answer will be 13/15.